So let us take this problem. A capacitor of capacitance of 100 microfarad is fully charged to voltage of 5 volt. 5 volt ಗೆ charge ಮಾಡಿದರೆ, then capacitance of the capacitor is 100 microfarad. It is found that during discharging through a resistance, current falls to half of its maximum after 23 seconds. After 23 seconds, the current through the circuit falls to half of its maximum, and calculate the value of the resistance. Okay, just you see what are the given quantities. Solution of the problem given: C equal to 100 microfarad is given, that is 100 into 10 to the power 6 farad. Micro means 10 to the power minus 6. Then battery voltage or maximum voltage of the capacitor is given, that is 5 volt. Then it is given that at t is equal to 23 second, current will be half of the maximum, that is I0 by 2, where I0 is the maximum current. Okay, so I will be I0 by 2 at t is equal to 23 seconds. That information is given. And here I0 is the maximum current at t equal to 0. That is before discharging. Just before discharging, the maximum current was I0. After 23 seconds, the current decreases to I0 by 2, half of the maximum. Okay, and you have to find the value of the resistance. Now we have the discharging current, which is equal to I equal to I0 into e to the power minus t by RC. This is the formula. So we have to put this condition. So information given is at t is equal to 23 seconds, I will be I0 by 2. Okay, so therefore at t is equal to 23 seconds, so this formula becomes equal to I0 by 2 is equal to I0 into e to the power minus 23 divided by RC, R into 100 into 10 to the power minus 6. R anna now calculate madbeku. We have to calculate the value of R. T is 23 seconds. I0 I will keep it as it is. At 23 seconds, current will be I0 by 2. So left hand side will be I0 by 2. So I0 gets cancelled. So you will get half. So I0 gets cancelled. On the left hand side, you will get half is equal to e to the power minus 23 divided by R into 100 into 10 to the power minus 6. I will keep it as it is. Now take log on both sides. Take log to the base e on both sides. Eradu kade log annu tagodri. Okay. Then that will be ln of 0.5. Ln is nothing but log to the base e. Ln of 0.5, because half is 0.5, is equal to log of e to the power minus 23, and so this term becomes minus 23 divided by R into 100 into 10 to the power minus 6, because log of e to the power x is equal to x. So therefore, you will get this particular quantity. Then rearrange, solve it for R. Resistance and now find out madbeku. Solve it. Okay. So therefore, this R will be equal to the value of resistance. R annu ee kade tagolri. So R will be equal to minus 23 divided by 100 into 10 to the power minus 6 into ln of 0.5. Okay, that value you get. Okay, E value bantu. So R will be equal to minus 23 divided by 100 into 10 to the power minus 6 into ln of 0.5. Solve it. You calculate ln of 0.5, log to the base E, okay, of 0.5. So it will have the value minus 0.69. Okay, so ln of 0.5 is minus 0.69. Then finally, you calculate the values. So minus here, minus into minus become plus. So it will be 23 divided by 100 into 10 to the power minus 6 into minus 0.69. Okay, if you calculate, the value of R will be 0.333 into 10 to the power 6 ohm. If you convert that into kilo ohm, you will get R value is equal to 333 kilo ohm. So that is the resistance connected in the circuit. Okay, so this is the problem on discharging of the capacitor. Okay, so current will become half of the maximum at 23 seconds. That is the information given. According to that, you can calculate the value of resistance. Let us take this particular problem, a circuit containing a resistance of 20 ohm and inductance of 1 Henry in series with a battery of 50 volt. This is a series RL circuit problem. Here resistance of 20 ohm and the inductance of 1 Henry is connected in series with a battery of 50 volt. Okay, I think we have solved this problem. Okay, you just solve ಮಾಡಿದ್ವಲ್ಲ ಇದನ್ನು. Let's take this problem. A 50 microfarad capacitor is connected in series with a resistance of 2 mega ohm, and this combination is connected to 15 volt battery. So this is a series RC circuit problem. Okay, a capacitor of 50 microfarad is connected in series with the resistance of 2 mega ohm. Mega means 10 to the power 6. Determine, first question, time constant of the circuit. You have to find a time constant of the circuit. Second question, maximum charge on capacitor if it is fully charged. Okay, you have to find maximum charge on capacitor if it is fully charged. Then third question, charge on capacitor at a t is equal to 50 seconds. Three questions you have to find. First question is you have to find the time constant. That is the first question. Second question, you have to find the maximum charge on capacitor if it is fully charged. Maximum charge Q naught you have to find. Then third question, what is the charge on the capacitor at t is equal to 50 seconds. It is a charging of capacitor problem because the capacitor and resistor are connected to a battery of 15 volt. Okay, so let us solve this solution. So what are the given quantities? The given quantities are C is equal to 50 microfarad. Capacitance of the capacitor is given 50 microfarad. That is equal to 50 into 10 to the power minus 6 farad. Micro means 10 to the power minus 6. Then resistance is given. It is 2 mega ohm. That is equal to 2 into 10 to the power 6 ohm. Okay. Resistance is 2 into 10 to the power 6 ohm. Mega means 10 to the power 6. Then voltage of the battery, which is given 15 volt. The maximum voltage to which the capacitor can be charged, that is equal to 15 ohm. That is equal to the battery voltage. Now one by one we'll calculate. So first you will find out what is the time constant of the circuit. So this is a series RC circuit. You find the time constant. So what will be the time constant of the circuit? What is the formula? T is equal to R into C. Can you calculate? So time constant of the circuit, R is given, C is given. Eradu kottidare. You have to calculate time constant by taking the product R and C. R into C. So what will be the value of time constant? Anyone? Okay, let us do this. So substitute for R and C. So R is 2 into 10 to the power 6 ohm. C is 50 into 10 to the power minus 6 farad. So 10 to the power plus 6 into 10 to the power minus 6. These two gets cancelled. This is equal to 1. Okay. So 10 to the power plus 6 into 10 to the power minus 6. So this is 10 to the power 6 minus 6. That is 10 to the power 0. 10 to the power 0 is 1. So it gets cancelled. So simply you will get product 50 into 2. So what is the value of 50 into 2? That is equal to 100 seconds. Right. So this is very simple. Just you remember 10 to the power 6 into 10 to the power minus 6 is equal to 1. Okay, those two gets cancelled. So simply you will get the time constant of the circuit T is equal to 100 seconds. Then second question, you have to find maximum charge on capacitor if it is fully charged. Okay, fully charged ಆದಾಗ ಎಷ್ಟು ಚಾರ್ಜ್ ಅದರಲ್ಲಿ ಸ್ಟೋರ್ ಆಗಿರ್ತದೆ, Q naught you have to find out. What is the expression for Q naught? During the charging of capacitor, you have studied that. Anyone?
V into C.
Right. So Q naught is equal to V naught into C. Okay, V into C, that is right. We will take V as V naught. Maximum charge Q naught is equal to V naught into C. What is V naught? V naught is the battery voltage. Okay, that is the maximum voltage. C is given, V naught is given. Just you calculate. So maximum charge on the capacitor is Q naught is equal to V naught into C. What is the value of V naught? It is 15 volt. C is 50 microfarad. That is 50 into 10 to the power minus 6. Okay. So therefore, if you substitute, it will be 15 into 50 into 10 to the power minus 6. So 50 into 15, that is 750. Okay, 15 5s are 75 into 0 into 10, that is 750. 750 into 10 to the power minus 6 coulomb, because charge, the unit of charge is coulomb. So 10 to the power minus 6 means it is micro. So I can express the maximum charge Q naught as a 750 microcoulomb. Okay, so maximum charge on the capacitor is given by Q naught is equal to V naught into C. Therefore, Q naught is equal to 750 microcoulomb. That is the unit of charge. Coulomb is the unit of charge. Then third question, ಮೂರನೇ question ಏನಿದೆ, you have to find the charge on the capacitor at t is equal to 50 second. At t is equal to 50 second, what is the value of Q? What is the expression? So charge on the capacitor at t is equal to 50 second is given by Q is equal to Q naught into 1 minus e to the power minus t by RC. Direct formula you have to use. So Q naught is known. Q naught just you have calculated. Value of R into C, you know, it is 100 second. Okay, time constant RC is equal to 100 second. At t is equal to 50 second, you have to find the charge. So you substitute for t equal to 50 second, that's all. So Q naught is 750 into 10 to the power minus 6 into 1 minus e to the power minus 50 by 100. Okay, 50 by 100 is, it is 1 by 2. Okay, so it will be 750 into 10 to the power minus 6 into 1 minus e to the power minus 1 by 2. Minus 1 by 2 is nothing but minus 0.5. So this will be 750 into 10 to the power minus 6 into 1 minus e to the power minus 0.5. So can you calculate this value? If you calculate the 10 e to the power minus 0.5, that will be 0.606. The value of exponential minus 0.5 is 0.606. Okay. Can you calculate the final value now? So it is 750 into 1 minus 0.606. You first calculate 1 minus 0.606, then you multiply it by 750 into 10 to the power minus 6 as it is. So that is representing micro.
$295.5 into 10 power minus 6.
Yes. So if you convert that 10 to the power minus 6 as micro, if you express that as micro, it will be 295.6 microcoulomb. So 1 minus 0.606 is 0.394. If you calculate it, you will get 0.394 into 750 into 10 to the power minus 6. So you will get the value of Q is equal to 295.5 microcoulomb. So this is the value of the charge on the capacitor at a t is equal to 50 second. Okay. So let us take the last problem.